identical radiators have a separation of d is equal to lambda by 4, where lambda is the wavelength of the waves emitted by either source. The initial phase difference between the sources is pi by 4. Then the intensity on the screen at a distant point situated at an angle theta equal to 30 degree from the radiators is, here I naught is the intensity at that point due to one radiator alone. So I naught is the initial intensity. We know resultant amplitude of the interfering waves as 2a cos phi by 2, cos phi by 2, and we know intensity is directly proportional to square of the amplitude. So intensity will be 4 a square cos square phi by 2. Initial intensity is proportional to initial amplitude square. So it will be written as 4 I naught. Instead of a square I will write I naught cos square phi by 2. So this is the equation to be considered. Now let us come to the schematic analysis of the statement given setup. From source 1, one radiator emits radiation up to an angular displacement from the central maxima. It is at the location theta equal to 30 degree. Another source also emits same wavelength to this location, say x. The initial phase difference is pi by 4 and path difference is already, we consider it as sin theta. D sin theta is a path difference. So path difference total is initial path difference plus initial path difference and locational path difference, that is due to the location. Locational path difference. Had it been at the center between the sources S1 and S2, this locational path difference wouldn't have existed. Now it is not at the center, that is why that locational path difference also exists. So phase difference is what we require. Phi we need to calculate. Phase difference phi is initial phase difference plus locational phase difference. So locational path difference is actually d sin theta. Okay, locational path difference is actually d sin theta. Initial phase difference is pi by 4 plus locational phase difference is d sin theta. If you multiply this by 2 pi by lambda, this is path difference. If you multiply that with the 2 pi by lambda, it becomes phase difference phi. So now phi is equal to pi by 4 plus 2 pi by lambda. D is clearly given as lambda by 4 sin 30. Lambda cancels, 2 1s are, 2 2s are. So phi is pi by 4 plus pi by 2 and sin 30, another half. Pi by 4, this is pi by 2. Now going back to this equation, I is equal to 4 I naught cos square. Phi I have found out, that is pi by 2, and there is 2 in the formula. So this will be 4 I naught cos square pi by 4. I is equal to 4 I naught cos square pi by 4. Cos pi by 4 is 1 by root 2. Its square is half. So it is 2 I naught. The resultant intensity that we are going to get is 2 I naught at the location. Hence option B is the right answer.